What's going on, everybody? Welcome to part 10 of the machine learning or deep learning and Halite 3 series. Up to this point, we just kind of started talking about our constants, making our imports, talking about how we're going to structure things. Let's just go ahead and jump into it. So at this point, we've shuffled all of the files and we're ready to separate them out into training and validation files. They're already shuffled, so we can just iterate up to whatever the, validation amount is for the validation stuff, and then after that do the training. Also, we only need to do that once. We don't need to do that every time through the epochs. And like I said, I'm not going to use the TensorFlow generator stuff because I think it just overcomplicates things. It's just not really well done for the user, in my opinion. So we want to make sure we have some logic that allows us to just load this data one time, even if we want to, because basically we could also set this to true once we have those files and we don't have to load them at all. But if we do need to load in the data, we just want to load it in one time, not every time per epoch. All right, let's get to it. So first of all, we want to say if load train files. This means we have to load them. So now what we want to do before we even enter the epochs is we want to load in the validation files. So if load train files, so if we happen to have them, then we can just say test x equals np.load testx.npy, right? That'll be there. It's not there, so we're gonna have to because this is false anyways. But if it was, wouldn't that be nice? We could load it, but we can't. Therefore, else. So now what we need to do is basically we'll start with two empty lists, test y, and then we want to iterate over all of our files. So we're gonna say for f in tq dm. We're just going to use this to let us know where we are in each process. And then that's going to be training file names up to the validation game count. So the first, what is it, 50 I think we chose? Yeah, first 50. That'll be our validation data. So then what we're going to say is data equals np.load that file, that data. It's an entire game. So it's a list of lists where the list itself is a bunch of these, it's not really the game visualization, but it sort of is. It's just all the data from each of the coordinates basically on the game map that we're curious about. So that'll be so the 0th element is the 33 by 33 data. And then the 1st element is the move that was associated, what move did the agent make based on that data. Okay, so now, so data equals np loaded. Okay, so now what we need to do is we want to iterate over that data. So for d in data, we want to test x dot append d0, and then test y dot append d1, and that's all good. And also, probably append np array. So the y's don't actually need to be a numpy array, but I'm pretty sure the x data, I think TensorFlow is gonna bark at us if we don't go with an array for all the x data. Okay, once that's done, np.save and whoops, oh man, I hit my insert key or something. What is happening? There we go. Test x numpy. This is like the same time as that previous tutorial where I made an egregious mistake, so just go ahead and expect that this is not going to work. Really, any Centex video, just really keep your standards very low and everybody stays happy. Okay, so in this case now we save those files that later we would look for if we believed we could load it. Okay, so we've done that, and we can get away with that because it's only 50 files, and even when the files are like 50 megabytes each or whatever, we can still easily load in 50. But what about in this case where, we've got like 3,000 of these files that we're going to use, and while they're only 1 megabyte, that's no big deal, right? But when they're 50, it's a little bigger of a deal. And then what if we even have even more games? Like what if we have 10,000 games that we're going to go with? At some point we have to chunk these and load them in as batches. So that's what we want to do. Now the next question is, how do we separate these into batches? Well, there's a bunch of different ways. We could slice and then use some sort of counter that keeps adding, plus 50 and slices based on that. You really could do that. Or the thing I always do is I go to google.com and then I search split a list into chunks Python. This will probably get us where I want to be. How do you, click on this very first result, and this is a beautiful generator for doing just that. You pass the list, and then you pass how many items do you want in each of the lists, and it will just automatically chunk it. And then you can iterate over those chunks very nicely. I use this all the time. I find this to be one of the most useful Stack Overflow copy pastas that you could possibly make. So the other thing I'll do is just copy that, just in case I post this code somewhere. Source, blah. Okay, so great. Well done, everybody. Good chunking. Okay. Now, the next thing that we're going to do is define our neural network. Now, in the case, you might already have a previous model, just like before. So if load prev model, so if that's true, then you can say model equals tf.keras. Is it models? I think it's .models. Yeah, .models.load model, and then prev model name. Easy as that. We don't have a model, so it's else. And then we need to start specifying our model. So model equals sequential. We'll go with a sequential type of model. I think we're going to steal from myself. Let's go Keras again. And then that was what, part 3? Part of me just wants to just take a copy and paste that code. Let's go to the bottom. This looks good, huh? We don't want the binary cross entropy, but the rest should be fine. So I think what I'm going to do, everything down to that final dense layer, I think is what we'll take. So we will do this, probably. Let me just copy that. This is probably not going to end well, but hey, nothing ventured, nothing gained. Ooh, that looks like a regular tab as well. Let's fix that. No. I thought we fixed this before. What? Why are you... Oh my gosh, this is the whole thing? I could have sworn we... Oh, this is really painful. I thought I already set this. Why do I gotta do this again? Now I gotta fix all this because it's gonna probably get angry at me. But why I gotta do this? This is super annoying. There's gotta be like a better way to translate all this stuff, but and then we gotta do all these. That's really weird. I swear in... Now I've lost my mouse. Cool. I swear in one of the previous tutorials I fixed this already. I'm not sure why this one suddenly has real tabs. Anyways, definitely want spaces so we can transfer it to other places. Okay, where was I? So we probably don't need this. Let's do a 64, 64, and let's do a 3 by 64. Activation can stay rectified linear. That's fine. Flatten to a dense 64. We'll keep activation sigmoid. We don't have 1 now. We're gonna go with 5 options, and then we need to choose sparse. Sparse categorical cross entropy on the fitment. Also, it probably, let me think here on X. Well, we just don't have X. Also, by this point, we won't have any of the X's. So, in fact, what we probably need to say is test x.shape So we definitely need that thing to be a NumPy array at this point. Test X, but also test X itself is not a NumPy array. We need to convert that to probably be a NumPy array. Let me just do that here. Test X equals NP array test X. Because we still can't get a shape, because it's a list of NumPy arrays up until we do this. So we've got that. Then we've got this random function in there. That's fine. Well, we can clean this stuff up later. For now, let's make it work. I think we're almost done here. So the only other thing that has been coming up recently, padding equals same, is for some reason in the newer versions of TensorFlow, I get a lot of these like shaping issues. So I would recommend adding padding same to every convolutional in pooling layer. Hopefully that is where, I think that's all where it's meant to be. Because you have to specify it, and for some reason the defaults have changed, and then now if everything doesn't add up perfectly, you'll get an error, and it's really tedious. That's something that you would want to happen in the lower level TensorFlow, but not in the higher level TensorFlow layers API. I think that's really dumb that they've like gone back to having that stuff have to, you used to not have to think about it if you use the TensorFlow layers, and I think that is a better choice personally. But it is what it is. Okay, that's our model. Fantastic. So then we're going to specify our optimizer, and that's going to be tf.keras.optimizers.A atom, and then we'll say the learning rate. Whoops. Learning rate 0.001. So 1e negative. Let's just do it this way. 1e negative 3. We might find that 1e negative 4, 1e negative 5 makes more sense. I think to start we'll get away with 1e negative 3, but we'll probably end up having to check a few. Also, we could set a decay. Also, I'll set that to 1e negative 3. Okay, then model.compile, and we will say loss equals sparse categorical cross entropy. That's really long. We need like an SCC shorthand. I know they have it for like MSE, for mean squared error. We need SCC, please. Maybe that's a thing now. Someone try it. Let me know. Optimizer equals the opt that we just defined, and then the metrics that will track metrics equals accuracy. Fantastic. Okay, so step 1 is, let's see if this compiles. So Python centibot dot, oh no, that's not what I want. Frick. Python, it was train, not the part 9, but this one. Okay. Okay, so it looks like our model does compile, and we are ready to go through epochs. Back to our code. Lovely, lovely code. Okay. So now, for E in range epoch, whatever that was, print currently working on epoch E. Cool. So we'll know which epoch we are on. Then what we're going to say is training file chunks. That is equal to that chunks generator that we built here, and then you pass L and N. So the entire list is all of our files. So that's training file names after the validation, or I'm sorry, whoo, almost messed up there. Okay, so validation game count onward, and then training, what is it, training chunk size, done. Okay, I said fudged, by the way. Okay, training file chunks, probably actually just define that up here. That should be fine to put that up there, because we don't need to define that every epoch. Okay, great. 4, index and training files enumerate training file chunks. Print working on data chunk IDX plus 1 out of this, out of this divided by training chunk size. So that might wind up giving us quite the long, so let's say round that to 2 decimal places. Otherwise that might be like a super long decimal or something. And really what we should say is math.ceil, but I'm not going to do that. I just want the general gist of where we are. Okay, so now what we'll say is if load train files or e is greater than 0. So if we've already done one whole epoch, we have the data. So we can actually say x equals np.load, and then we'll call this x dash something.npy, and this would be idx, as if I'm asking you guys. But yeah, that should be what you want. Copy that, paste. Otherwise, y equals np load y under the ideal scenario. Then else x equals empty list, y equals empty list. For f in tqdm training file training files. What do we want to do? We're going to say data equals np.load f. Really, this is all pretty similar to what we had before. Also, we still haven't balanced anything. We'll get to it. Data equals np load f for d in data. Let's say x dot append np array d 0, y dot append d 1. Okay, same code as we used before. If anything, probably make that a function or something, but I'm not going to worry about it. Okay, now we need like a balancing function. And this kind of sucks. There's got to be like a built-in balance that we could plausibly use. I'm gonna say _1. So we'll do this for each of the lists. It's almost embarrassing. Probably shouldn't post this, but we gotta balance it. There's got to be like a built-in balancing function, though. Such a common task. For xy in zip xy. Basically, we need to get to the point where all of these lists are the same length. So usually what I'll do is I'll iterate through the data, separate them out by their classifications. Then you find the min length, and then you make all of the lists. You just slice them up to that minimum length, so the lowest one. So kind of lame that we're going to do this, but this is, you got to balance it. And like I said, there's probably out there some really great balance function. And if you know of one, it would really make my day if you know of like a pre-existing one in Keras or something that is super easy to use. Most of the time, I don't really like their helper functions. But anyways, if y is equal to 0, we'll do _0 dot append what xy. Okay, then we're gonna do this again, sir. Start acting up on me now. So this is like one of those scenarios where I really wish it was acceptable Python practice to just do this and like have this on every line. Like, why can't we as a community come together and just decide that if we have a one very short line after an if statement, that we can put it on one line. It's okay. I really want that to be the case. 2, 3, 4, 5. If I wasn't showing it on video, I might. Shoot, I went the wrong way. Let's see. 1, 2, 3, 4, and then this needs to be 1, 2, 3, and I'm definitely violating another rule, which is anytime you got copied code, you're probably doing something stupid. So also, if you have a way to condense what we write here, even if it isn't something in Keras, post it below. Because again, I end up writing these stupid functions like every time, and it stinks. Min, len, so len underscore 0. So it will be the minimum of all of these lengths. So, dang it. Okay. That would be 1, 2, 3, 4. So 1, 2, 3, 4. Okay, so this tells us what the shortest list is. Chances are these are all at this stage. Min. Oh, and this also needs to be a list. So it should be a list of these lengths. Okay, so this tells us what the shortest list, the shortest, how long the shortest list is. Got it. Okay, once we know that, then we can just say 0 underscore 0 equals underscore 0 up to shortest. So let's say shortest is 1,000. It'll be 1,000 of all of these lists. So then we just do this for all of the classes. So like this, I feel like there's got to be some way to be like, here, there are n classes. The only problem is sometimes your classes are going to be one-hot vectors or arrays or whatever you want to call them. And then other times they'll be just scalars like I have here. But you could probably figure out each unique one and then somehow assign it. There's going to be a good way to do this. Somebody will save us at some point. Okay, so balanced equals, and then it's all these put together. So 0 underscore 0 underscore 1, and then let me just do this 2, 3. Okay, I don't even know what I hit. Hey, I thought this was gonna be easy. Okay, 0, 1, 2, 3, 4. So that's balanced. We'll do a random dot shuffle balanced. Cool. Just for our records, let's just say the shortest file was, and in this case I'll just use a comma here, and then what was it, shortest, just so we get the number. Okay, and then what we want to say is x's equals this, y's equals this, and in fact I kind of want to fix this print statement. I want a little more information. Okay, the shortest file was shortest total balanced length is, and this will be len balance. So that way we get a good idea, because after balance you might find that you have way less training samples than you thought. So once we've balanced the training data, we need to re-separate out the x's and the y's. So now what we want to say is for x, y in balanced, x's dot append x, y's dot append y, return x's, y's. Woo! Okay. Looks great. Good work, everybody. And I think, okay, so now coming down here, what we want to say is x comma y equals balance, x comma y. And then test x, test y equals balance. Because we're gonna have to reconvert test x to a NumPy array here. Don't forget that. Test y. So, and then also, it needs to be a capital X. And also, we did we call it, okay, test X, test Y. For some reason I thought I saw a capital X test instead, but I guess I didn't. My eyes are playing tricks on me maybe. Okay. Okay, we're good. So then what we need to do is convert all of these things to arrays. So we're going to say x equals np array x. I don't think y actually has to be an array, but we'll convert it anyways. Y test x equals np array test x test y equals np array test y. Okay, now let's do np.save and then f string, and we're going to call this x dash whatever I is. I think we're going to check to make sure that's right. I think I called it I, but I don't remember for sure. Y I, right? X dash, so it's IDX. Okay. Probably should make sure that works. But I want to go ahead and just finish the code up to this point. So in this case, we're loading in the files for IDX. So then what we'd like to do, like once you have the files in, we want to fit. So I'm going to say model.fit x, y. Batch size will be, we'll say 32 for now. Epochs equals 1 because we're handling epochs on our end. Validation data is equal to test x, test y. And we should do callbacks at some point, but I think we'll add that at the end. Let's just see if this fits. And depending on the error, we'll probably have to cover it in the next video because this one's getting to be really long. Sent a train. Also probably should make, I should probably make these chunks a lot smaller so we can dev a little quicker. If we do hit an error, I'll probably have to do that. This is already taking forever. I'm bored. So for now, I'm just gonna assume I'm gonna hit an error, so I'm gonna change these. Coming back, where are we here? Okay, balance x y. X is not defined. I assumed we would hit an error, and gosh darn it, was I right? So balance needs to be capital X. Try again, idiot. And also our fitment, I kind of messed up there as well. Another lowercase x. This should be out 1, I think. So yeah, so this should not happen in here because that was under the else statement. Then we would never train if we loaded a file. Let's see. Where was the other silly lowercase x? Right here. Save. Let's come back. Run it again. Try again, idiot. Did I really do 200? I should do 10 and 100. Save. We didn't save the actual array. I'm just going to lower this yet again. Let's make it 50, just so it's even quicker. I'm just trying to figure out, like, get this to work. So in this case, we want to save x, capital X, and then here we want to save lowercase y. Again. I would really like to see some training going on. That would just make me so happy. I expected way more errors. I can't believe we're training already, guys. Okay, so accuracy right now is pretty darn bad. But we should expect that accuracy will be around 20%. Don't forget, we're training on random data here. So we should only hope for slightly better than random results. So the fact that we're already at 22% accuracy, now 25%, what's my out of sample? Oh my gosh. Where's the out of sample? It's moving too fast. 26% validation accuracy, 28%. I would not even trust that at 28. We really should be like slightly better than random. Hopefully we don't. I want to start freaking out if we see like a 30 or something. We should be pretty close to random is my point. But we do have a pretty good threshold. But we just shouldn't be that far, at least on the first iteration. But this is looking pretty darn good. Okay, so what I'm going to do is I'm going to break it here because these are way too small of pieces. Also, the validation set is arguably way too small. So we're going to go back to our original 50 and our 500. And then the other thing we should be doing is... Come on, man. After the fit, so the fit is through every index. You could either save a model every iteration or every epoch. You can decide what the heck you want to do. I'm guessing only one epoch is going to be required. But definitely I would save at least every epoch, and at least I'm going to do that. But a part of me says, might as well just save it every iteration. So I would say model.save. So it was called model name or something like that. Wasn't it? Maybe it was just name. Was it just capital name? Yeah. And I can't remember if name has a time associated with it or not. It does. Cool. Okay, good enough for me. And the next thing I also wouldn't mind doing, so model.save name. Also, let's save that to models/name. Cool. So we'll also need to create that models directory. New models. Very well, very well. And finally, this tutorial will end at some point. At this, probably before we load in the model, let's define TensorBoard. And that's going to be equal to TensorBoard object. And then we specify logdir equals, and again, f logs / whatever the name of this model is. And then we come down to where we do our fitment, and we need to add in the TensorBoard callback. So it should be callbacks. Callbacks is a list. And we want to pass, shoot, I think it was just lowercase TensorBoard, if I recall right. Let me check. Yeah, okay. TensorBoard. Come up here and confirm TensorBoard. I just want to make sure I didn't typo this. I'm going to be really angry if I hit some freaking error at this stage. Okay. All right, I think we're all set. So models, and then I can't remember if you have to have TensorBoard, the log.dir made, so I'm just going to throw in logs as well, just in case. And now, let's go. I'm going to cut the video here. If I hit any errors for whatever reason along the way, I will throw in a little update at the end of this video. Otherwise, I'm going to let this train. We're going to check out some of the results. I might do some tweaks or whatever. And then in the next video, we'll talk about the results and then hopefully have time to apply it to, actually start training, making new games based on that model and all that stuff. So that's what you guys have to look forward to. If you have questions, comments, concerns, suggestions, a better idea for the balance, whatever, feel free to leave those below. Otherwise, I will see you guys in the next video. And I kind of want to let this epoch finish just to see. But I think it's, hopefully, I'm going to be really shocked if we're like beyond 30 percentages, but okay. Validation. And we actually got a better validation accuracy than in sample. Interesting. Okay, see you guys later. All right, it wouldn't be a Centex video without a mistake and an edit at the very end. So I was trying to compare, I ran the first epoch, which, really we stuck around the range of 24 to 28, which for, validate, well, actually, I'm looking at the wrong thing. Let's look at epoch validation accuracy. We go to relative, and we can see where we've stayed at, somewhere between 24.5% and 25% accurate, which, in my opinion, is actually pretty good. So those are the results. But I was trying to do multiple epochs, and I stumbled on, hello, there we go, this. So what's going on? So the first one, I set it to run for 3 epochs. This is epoch 0, and then it just skips epoch 1, 2. It doesn't do anything. The issue is our generator. I moved it thinking that was the smart thing to do, but no, that was the stupid thing to do. What we need to do is put this back where it was. So for each epoch, we need to specify that generator, because if we don't, what happens is that it becomes empty. So we need to put it down here. Despite the fact that we're loading the files we actually only need to load them one time. There's probably actually even a better way, because the only really this should be up here, and then maybe this here needs to be something that calculates how many chunks there would have been or something like that, but I'm not going to worry about that for now. What I am going to say is the easiest fix is to just throw this back down into there. And then now we should be able to get 3 full epochs. Just for comparison's sake, I just want to see more epochs and see, does that help? Does it do anything? Does it hurt or whatever? So back to training. Okay, see you guys in the next video.